I don't want it unless it has caffeine. All right. So here we go. The test is probably Wednesday. It's for sure not tomorrow. Probably Wednesday. All right. Did we talk much about this? I don't remember. We talked about molality. It is moles of solute over kilogram of solvent. Now, I'm going to show one of Tyler DeWitt's videos about the difference between the two. It's 5 minutes. I think it has value. Where is it? I need to share computer sound. And I'll just get that going here for a second.
And molality. Wow, these are two names that sound very similar. So what are they for, and what's the difference between these two things? Well, molarity and molality both measure concentration, right? Like the amount of solute that's dissolved in a certain amount of solution. So molarity and molality are both measures of concentration, but there are very important differences between them. So molarity is defined as the number of moles of solute you have divided by the liters of solution that you have. Molality, on the other hand, is also the moles of solute that you have, but it's divided by the kilograms of solvent. So molarity is about liters, the amount of space something takes up, whereas molality is about mass, how much something weighs. But there's a more subtle difference between molarity and molality that like always trips people up, and teachers and textbooks love to quiz you on it. Here's the thing. Molarity is about liters of solution. Okay, so the liters of solution here mean the solute and solvent combined. That's what a solution is. It's a solvent and the solute together. So the liters of solution is the solute and solvent combined, whereas in molality, we're talking about the kilograms of solvent. So this is the solvent just by itself, okay? So that is one important difference, and let me show you what that actually means and why it's important. Let's talk about making a molar and a molal solution of calcium chloride, which has a molar mass of 111.0 grams. So to make 1 molar solution of CaCl2, I'll take 111 grams and dissolve it in 1 liter of solution. And to make a 1 molal solution of calcium chloride, I'll take that same 111 grams and dissolve it in 1 kilogram of water. But here's how I'll actually do this, and this is where the difference comes in. If I want to make a 1 molar solution, I'll go to the scale and I'll weigh out 111 grams of calcium chloride. I'll then take a volumetric flask like this one, and I'll take the calcium chloride and I'll empty it into here. So now I have the calcium chloride here on the bottom. And what I'll do is I'll add a little bit of water to it and swirl it around until the calcium chloride, which was here, dissolves in the water. Okay. Now check out this line up here, 1 liter. That's what the mark is. Now I'll take water and I'll add it to this flask right up until I get to the 1 liter mark. And now that I know I have 1 liter of solution, I have 1 molar solution. Okay, now this is different with molal. In that case, I'll still go to the scale and weigh out 111 grams. But then instead of using a flask or a beaker or anything, I'll just take a container and I'll put that on the scale and I'll weigh out 1 kilogram of water. And then I'll just take the calcium chloride and I'll dump it in the water and I'll mix it together. And there's my 1 molal solution. So the point is, here I mix the solute and the solvent together, and then I increase the volume of both of them together until it gets to 1 liter. Whereas this, I do the solute separately and the solvent separately, and then once I mix them together, I don't care. So there are 2 important things to keep in mind about molarity and molality. One is you might know that 1 liter of water weighs 1 kilogram. Okay, so that confuses people sometimes because they're like, wait, but molar and molal will be very similar because 1 liter of water weighs 1 kilogram. Okay, that is true for water, but it's not true for many other solvents. So for example, if you're making a solution of oil, where oil is a solvent or alcohol is a solvent, 1 liter is not going to weigh 1 kilogram, so there will be a difference. Now here's another thing. People ask, why do we even do molality? Because usually concentration is measured in molarity. What's the point of molality? Well, here's one important thing that makes molality easier. With molar, you got to take a flask, you got to measure the volume, you got to pull it up to this 1 liter line. Whereas when you're making a molal solution, all you need is a scale. You just weigh out the solute, you weigh out the solvent, and you mix them together. So that's a big advantage of molality over molarity. There are some other technical differences between molar and molal solutions, and if you're interested in those, check out my next video, which is called What's the Point of Molality? When we're talking about concentration of a solution, we usually describe it in terms of molarity, moles of solute divided by liters of solution. So then, what's the point of molality? It has a weird name, and it's all about kilograms of solvent. Well, molarity is more common, but there are some situations where molality is a better measure of concentration. I will talk about 2 of them. First of all, it is easier to make a molal solution than a molar solution. Here's why. If I want to make a molar solution, let's say I want to make a 1 molar solution, I'll take 1 mole of solute, I'll weigh it out, and then I will put it in a volumetric flask like this. There's a solute, I've dumped it here into the flask. Then I'll add a little bit of water to dissolve the solute. I'll swish it around, and then until it's dissolved. And then I will very carefully take additional water and fill it up to this line right here until it's exactly 1 liter. That can be kind of a pain because you have to have a good flask and you mix it together, and then you still have to add water to pull it up right here to the line. Stays constant over a weight. It is a scale to weigh out the solute and the solvent and then mix them together. So that is one advantage of molality. Here is another advantage of molality. Molality stays constant over a wide range of temperature and pressures, whereas molarity can change. Let me show you how this happens. So let's imagine that right here I have a 1 molar solution, 1 mole divided in 1 liter of solution, and I've made this solution at 60 degrees Celsius. As I said, it's 1 mole in 1.000 liters. It's very precise. And 1 mole in 1 liter is going to give me a 1 molar solution. Okay, now here's the thing. You may not know this, but water and a variety of solvents can expand or contract depending on the temperature or the pressure. So if we cool things down to, say, 4 degrees Celsius, check this out. The water that used to reach the 1 liter mark here has now contracted so that I have less than 1 liter of solution here. And then on the other hand, at temperatures above 60 degrees, the water will expand. So instead of 1 liter here, now I have more than 1 liter of solution in this flask. So the volume has gone down here, but the amount of solute has not, because the solute's still just dissolved in the solution. So now I have 1 mole of solute, but it's only in 0.974 liters because the volume has gone down. And then on this, in this example here, where the water expanded, now I have 1 mole of solute in 1.025 liters because it went up. Since we get molarity by taking the moles and dividing the liters, this is going to change the molarity. So now in this situation, because I have less volume, so I'm dividing by a smaller number, my molarity is actually going to go up because the water contracted, and because the water, the solution expanded here, I get a smaller molarity. Now you could say that these aren't huge differences, and they might not be depending on what you're doing. But if you want to have a solution at a very precise concentration, it could matter under certain situations if you have a concentration that is greater or less than 1 molar. On the other hand, while water can contract and expand, its mass will never change. So that means that if you have 1 mole in 1 kilogram of water at 60 degrees, even if that water expands, it will still weigh 1 kilogram. So I will have 1 mole over 1 kilogram of water at 98 degrees. So I also have a 1 molal solution here, like I had a 1 molal solution here. And again, if that water contracts a little bit, it's no big deal because the mass is still 1 kilogram. So I get a 1 molal solution. So it's constant no matter how the solution might expand or contract. So to sum this up, what's the point of molality? Despite the fact that it's sometimes easier to make a molal solution, we can say that while molarity may change at different temperatures and or pressures, molality remains constant. And that can be a big advantage of molal solutions.
So after all that, it might not seem like it's still that big of a deal. But are you raising your hand? Okay, you're not. We fast forward to colligative properties, okay, that was too far. A colligative property, which we'll learn about, is when the freezing point or the boiling point changes based on the concentration of a solution. And if you think about the temperature difference between a boiling point and a freezing point, it's important that we use a concentration that doesn't change with temperature. Because if we use molarity, we'd have to have a temperature like a fudge factor for every single problem. So we aren't here yet, but the whole reason we're finding molality is for these colligative properties, they're coming up soon. In fact, right there. Okay, so it's not absolutely imperative that you understand what molality and molarity are and the differences, but knowing how to calculate them and when to use them, that's absolutely imperative. So let's jump into it. So he just said this 100 times. Molality is not temperature dependent. All right, when you're given a molality, it's usually given to you either in a problem, and it's just written like 1.95 molal, or a little m. And it's not very common that it's a little m. It's almost always molal. So remember, if you see molal, that's short for molality, and it means moles per kilogram of solvent. This is where you mess up the most. It's not solution, and this would be solute. Okay, now, most problems, they will give you either molarity and ask for molality, or they'll give you molality and ask for molarity, or there's a third option. It won't give you either. It'll ask you to calculate both given the amount of stuff and some volume. So we're going to work through all those. Yes, sir.
Are we going to have to convert to kilograms, or will it be given in kilograms?
You definitely will have to do some kilogram conversions. So let's just talk about that. 1 kilogram is 1,000 grams. So you should be comfortable because we've been converting milliliters and liters the whole time. It's the same math. Move it 3 one way or the other. Okay, changing molarity to molality. We're going to work on that right now. This is only possible if we know the density. Now, I personally don't even understand this graph or graphic. So I wouldn't stress about that. Like even I was like, I'm finally going to figure out what they're even trying to tell me here. I was still lost, and I've taught it for 15 years, whatever. But if we have density and molarity, we can find molality. If we have molality and density, we can find molarity. I think I said that right. So let's just dive in here. We have a question, and you will have questions like this, for sure, without doubt, I promise you. says, what is the molality of NaCl in an aqueous solution that is 4.20 molar, and the density is, this is nice, I guess, 1.05 times 10 to the 23 grams per liter. It's almost always given to you in grams per milliliter. Yes. It's going to be 1050 kilograms.
Oh, so it's giving it to you, so yeah.
Yeah.
Isn't that the answer to number one pretty much though? Because it's just saying that's what it is grams per liter, right?
Well, I don't know why it's in scientific notation. And yes, it's sort of the answer, but it's also, I mean, you have to change it to the 1050. But as long as you can see it, yeah.
Oh, yeah.
Okay, so these are the 4 steps you should do. So when you have molar, so when given molarity, now I know it doesn't say molarity, but it says molar. Molar and molarity are the same thing. All right, and then it gives you density. When given molarity and density, I'm getting worse here. What's happening here? Whatever, that's an and sign. These are the steps you use to find molality. All right, and these aren't super complicated if you just follow the steps in order. And I know I say that about everything, so like this kid out in the hall saying, maybe I'm a liar. Here we go. So we use the density of the solution to find the mass of 1 liter of solution. Then we find the mass of the solute. Then we subtract the mass of the solute from the mass of the solution to find the mass of the solvent. Then we divide the given moles. And if you'll all look, what's molar? Or sorry, what does molar mean? 4.2 moles. So that's just given to me per liter. All right, so I know the moles. Divide the given moles by the mass of the solvent to find molarity. Okay, so let's attack. Are we ready? Use the density of the solution to find mass of 1 liter of solution. So I take 1 liter and I multiply it by, I'm just going to say 1050 if you're okay with that, grams per 1 liter. And it's just 1050. And that's the grams of solution. And please remember, solution is always 2 parts, solute and solvent. In order to solve for molality, I need moles per kilogram of solvent. So I'm using these steps right here to get the kilograms of solvent. Okay, find mass of solute. You may want to add this to your notes if you want. To find the mass of the solute, you take the given moles, which is 4.2 moles, and you multiply it by the molar mass. So 58, I round this one to 0.5. 58.5 grams per 1 mole. And this you could do as a picket fence as well. Okay, we've used that for a long time. 200 and something. Anyone do that yet?
It's 2000. Wait, no, it's not. Sorry.
It's okay.
And 245.7.
All right, that's grams of NaCl that are in this 4.2 molar solution. So remember, to find the mass of the solvent, we take the total of the solution and subtract, okay, I'm subtracting this way, the mass of the solute.
All you're doing with the solute is just anything you do for any other substance, right? Because moles times
Molar mass. There you go. It gives me the grams. Okay, so 1050 minus 245.7 equals,
804.3.
all right, and that would be grams of solvent. Then I'm pretty much ready to go. This really means it is 0.8043 kilograms, right? Don't forget that. That's always a heartbreaker. So now I know the kilograms of solvent. I take my given moles, which is 4.2, and I divide it by 0.8043, and I end up with what? Probably 5 point something, maybe 4.8 or 9. Okay, it's a very organized process.
Y'all can't keep saying that. That is my thing.
Unfortunately, no. That looks more like an axe, actually, this time.
I would like to revoke the rules.
Everybody?
Them use every time they say my thing.
I'll think about it. Okay, are we sort of all right with that problem? It's these steps. I'm pretty sure I have another one coming right up. Okay. Nope, it's a little different. So let's do the same problem. I'll leave this up here, but I'll just change everything. What is the molarity of LIF in an aqueous solution, which is 2.8 molar? The density of the solution is 1.15 gram per milliliter.
That's a lot smaller than before.
It's actually bigger than before.
It was 1.05 times 10 to the third.
But this was per liter.
Oh, per milliliter. Okay, never mind. That makes sense.
What is the
I see what you're saying.
What's that?
I'm just talking to myself.
Oh. Okay, so follow, I mean, it's the same process. I didn't change a whole lot. I know. All right, so we already did this part. Step one, we assumed we have 1 liter of solution or 1,000 milliliters. So we multiplied it by the density. I did it in a picket fence this time. You don't have to do that at all if you don't feel like it. Okay, so that's that. Number two, step two, find the mass of the solute. So we take the molarity, that's 2.8 moles. And we can say it's just 2.8 moles because when we assumed this part, we know molarity is moles per liter, and we already did the 1 liter. So that's how we know this is just moles. All right, then once again, you don't have to do a picket fence, but we can. For every 1 mole, how many grams are there of LiF? 26 grams. And that number turned into what? 72.8. I got a sneeze coming. I'm gonna probably take that mask home and wash it. All right. So step number 3, I'm gonna just say right here. I take my 1150 and I subtract my 72.8 because remember this is solution. This is solute. This answer will give me solvent. All right, now that's grams. So I move the decimal over 3 places. I have 1.0772 kilograms. Step number 4. You okay if I do that right here? It's kind of ugly, but whatever. Are we good back there? We take the given moles, which was 2.8, and we divide it by the kilograms, 1.0772, and it is equal to 2. Okay, molal. That's actually really hard, so it was pretty impressive. Okay, who had that right? Raise your hands.
I did. Can we take this moment and just
No, we will do definitely more than this
Do
on
you
the
all have
test.
words in the back of this classroom, John?
I don't.
This is my opinion. Like the heck?
All right, 2.6 molal. Not too bad. Just a little side note here. The closer your density is to 1 in general, the closer your molarity and your molality are to each other. So it does depend on the molar mass of stuff, but just in general, that's a pretty good indicator of whether you got the right answer or not. Okay, you good, or do you feel like you need one more or not? One more. Okay. Okay, I have one that I worked on today. Okay, so it says, let's see. Hey, don't fight. That's my number one thing I say at my house, by the way, to my children. I love them. Oh my. Yeah. Now this would be written in sentence form, but just go with me. Okay, give that a shot. There we go. Okay, the steps are similar. They're very similar, but you don't like exactly reverse it. So the first step you need to do is always assume 1 kilogram of solvent. Oh, that's fine. We're going the reverse now. This is your molal. We're solving for molarity. So this is the reverse. All right, we still need the 2. We need density and the molality, but we're solving for molarity. So we assume 1 kilogram of solvent. All right, next step. We're going to find the total mass of the solution. Sorry, solute. Okay, we can do that the same way we did before. We'll do it here in a minute, but that would be the next step. Third step, find the mass of solution. The hydrogen fluoride or hydrofluoric acid is technically what this is. Now, find the mass of the solution is just these 2 added together. the sum of those. So it's always 1,000 grams plus whatever this is. All right, use density to solve for volume. Then solve for molarity. So it really is similar. Instead of solving for volume now, or sorry, for mass using the density, which we did before, we now use it to solve for the volume. Okay, so we'll just attack. So I assume 1 kilogram of solvent, that's easy. Next, find the mass of the solute. That's the same thing we did before. I take the number of moles. So if I number these. So number 1, I'm not going to write down here, but just know that I'm saying 1,000 grams of solvent. Number 2, find the mass of the solute, 21.4 moles of HF. I want to know the grams of HF. So that's just 20, isn't it? 20 grams per 1 mole. And I already did this math to save us some time. I got 428.21.
Wait, why did you put moles?
Shouldn't it be molal?
Okay, well, it is molal, but remember it's moles per 1 kilogram. So just like before, by assuming 1 kilogram, I can just say I have this many moles. And we did that with molarity. By assuming we had 1 liter, we got rid of the liter and we knew we had just that many moles. It's cheating, but it's cheating by following the rules. I don't know how to. All right, so this is the mass of the solute. We okay with that? So that's up here. It's 428.21. The mass of the solvent is 1,000. And we just add them. That was ugly. But I get 1428.21 grams of solution.
Where did you get the 1,000 from?
Because we're
Right here.
using 1 kilogram.
Oh, okay.
1 kilogram
1,000 grams.
is 1,000 grams.
So it will always be 1,000.
Yeah, always, 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 because then it makes my molarity, it makes my molality and my moles the same number. If I assume anything else, I have to do way more math. So always assume. What's that? Yeah, we can choose whatever number we want, but choose 1 because math was 1 is easy. All right, now this is the grams of solution, but molarity is moles per liter, right? Now remember, I know the moles are just the number of the molal. So I need liters. And so that's for this 4th step. Use density to solve for volume. We can do that. We know the grams. I know the density. So I just set them up. I'll just do it right here. 1428.21 grams. All right. And I want to get rid of the grams and get molarity or milliliters. So I need grams on the bottom. So my density is 1.101 gram per 1 milliliter. The grams disappear. And I type this. Uh-oh. Come on. I already typed that in. You get 1297. I'm just going to leave it at that. Milliliters. Or, just like the other one, I need it in liters. So it's 1.297 liters. So that's my volume. Hold on. Okay, now you can wait. What, Grace?
Oh, Okay, so we're using the 21.4 mole, and then, wait, where's the 1.297 come from?
Came from up here.
And that,
In these steps, I found my, hold on, I like this lately. In these steps, I found the total mass of my solution. I can use mass and density to solve for volume. Density was given grams per milliliter. I knew the total grams, so I can find it's 1297 milliliters, but I converted that to liters.
okay, I was just confused because I don't know.
That's okay.
Wait, or can you just use the thing where you go density equals mass divided volume? That's what you just.
That's what I just did.
Oh. You just, okay, but you just take a 10 right there.
Yeah, like I said, it was on this slide, I think. I said, you don't have to do it as a picket fence, but I did. But yeah, it's the same thing. D equals M over V. All right, so you end up with 16.5 molar solution. All right, how fun was that? 16.5 molar solution. All right, last problem. Take a picture of this or something and try and see if you can do it tonight. 45 grams of NaCl solid is added to water. Actually, I mean, if I'm going to be friendly. Hi, guys. Oh, my heart was terrible. That's okay. 45 grams of NaCl is added to water to make 2 liters of solution. What is the molarity and molality of the solution? The density is 1.08 grams. This is something, it's written slightly different, but it's not, it's actually easier. You don't believe me? Okay, so try and see if you can reason your way through this one tonight. We'll talk about it tomorrow. We're out of here in 1 minute, right?
Yeah.
Okay.